If you're watching this video, it means you wanted a little bit of a walkthrough on this activity. What I will say before you get started is we're just trying to have a sense of something called completing the square. The goal of that is, for completing the square, is at this point and for the test next week, the only two skills you can use on the test to solve for x, for a quadratic, are factoring and taking square roots. So that we're really going to focus in to make sure you have those skills down next week. After that test, we're then going to open it up to something else, or a few other things, but one thing called completing the square. What it really is turning a quadratic into something that you can solve by taking square roots. So sometimes we'll scan a set of quadratics and be like, those two I could solve using square roots, but the rest of them I can't, right? Some of them work, some of them don't. What this skill will allow you to do is, and again, this is not for the test, but is to be able to solve a quadratic by taking square roots. Even if it doesn't start out that way, it's how you can turn it into that. So that's the plan. What I would like you to do right now is work on slides 1 through 7 as best. Pause this video in a second, and then work on slides 1 through 7 as best you can, and we're going to pick up together at slide 8. So please actually try them. You don't need to take a ton of time. If you get confused, that's okay. Do your best on 1 through 7, and then unpause the video. Okay, so you tried 1 through 7. The idea here, if you all notice, is the area of this is meant to represent a quadratic, right? So if I'm imagining these lengths, the blue square is an x by x square, and then we just have these little green rectangles is the word I was looking for. So this is meant to represent something that you couldn't take square roots to solve, right? Like if I look down here or up here at this expression x squared plus 10x, if it were equal to 0, this is not set up to take square roots to solve because I have this 10x, this linear term. However, what I can do, and why you were kind of messing around with the shape of it, is this area is not going to change as long as I still have my one square is what I was looking for. One, and then how many? 10 rectangles. So I still want one blue square and 10 of the green rectangles. And if I move them around in different spots, it's still the same area. So what I'm trying to do here, so now I still have my 5 green, which adds up to 10, plus we're still anchored in that blue square. I don't know why I'm having such a tough time associating the color with the shape, but here we go. And now what we're filling in, so we move things around, and the x squared plus 10x represents the green and the blue. And then that kind of like tan color is representing what we have to add in to create a new square. Like what we started with itself, the whole thing with green and blue wasn't a square. The tan is what we've got to add in to make a square, okay? And how we're going to do that is we're going to look, if we could just straight up count the number of little tan colored squares here, or pinkish squares. Or we could say, all right, this is 5 by 5, right? 5 times 5 is 25. So what I'm going to do in here is add 25, okay? When you factor x squared plus 10x plus 25, you are going to get, so the question is, what multiplies to 25 that adds to 10? The answer is positive 5 and positive 5, right? I can write that as x plus 5 times x plus 5, or I can write it as x plus 5 squared, okay? And notice what we've done here is if we add 25 here, we can write that as x plus 5 squared, which is something we could then take square roots to solve, okay? Let's look at this next one. So I want you to go through, you're going to pause the video and again in a second. I want you to go through slide 9 and just try it real quick. Pause it, try slide 9, and then we'll come back. Okay. Let's look at 10 together, because this is going to show us our balance. So this 64 here, don't worry about it. It's arbitrary. I mean, it's not totally arbitrary. It's going to work out to something nice. But imagine this is your equation, and I'm just trying to represent it visually over here, okay? So the question is, how can I rework this? I've got 12 rectangles. I'm going to split my 12 rectangles into 2, into 6 and 6, an even amount, because that will allow me to create this new figure that I could fill in the like pinkish tan squares to create a bigger square, okay? And when I keep saying square, I mean this like binomial squared here. That's what we're going for. We're going for something, all completing the squares, when you hear that phrase, which you will, is taking in a quadratic that you can't immediately solve using square roots and turning it into something that you can solve using square roots, okay? So I'm going to take, I had 12 rectangles and I divided by 2, okay? When we get to the notes, you'll see where that comes in. If I had 20 rectangles, I divide that by 2. And then whatever I get, so in this case, I took my 12 divided by 2, and then that got me a 6 by 6 that I had to fill in. So 6 times 6 is 36. So I'm going to add 36 on the left, because that's going to create something that I can factor into something squared. We'll see that in a second. And then why slide 10 is kind of a step up is because it's showing an actual equation. So just like anything we've done, if we add 36 to one side, what do we have to do? Add it to the other, right? To keep our balance. And then I'm just going to do one more little piece and then let you work through for a little bit. The factored equation on the left is going to be x plus 6. On the right is going to be still 64 plus 36, but that's going to get us 100. And then I just want you to notice in what's highlighted, and then I'll be finished talking. This is like set up very nicely to just take the square root of both sides, plus or minus square root of 100, which is plus or minus 10, and then subtract 6, okay? So I would like you to spend the next few minutes, I remember I'd limited it 20 or 15 minutes for the activity, do as much as you can, then be finished, transition to the notes.